Hello friends, I am Bharati from Learn Like a Child 1. Friends, last year we had focused mainly on 10th syllabus, but this year I am planning to teach you the complete mathematics 9th syllabus. So many videos will be on computer screen only. You will be seeing my face at the corner of the screen, but as it is a introductory, so I am in front of you. So in this year, I mean math 9th standard syllabus, we will be going to see all the concepts which are covered in 9th syllabus. By the way, 10 students, there need not be any tension, because as and when it is needed, I will be covering even few 10th chapters also. I am telling this because already I had uploaded 300 and plus videos on 10th math syllabus. I think that is more than sufficient, and whenever you need, you just go to my YouTube channel and you can see all my videos related to 10th mathematics. But this year mainly I am focusing on 9th, 8th and previous classes. So in 9th syllabus today we will going to be see a chapter on polynomials. So in polynomials, whatever all is there in your syllabus, I am going to cover. So let us start the chapter polynomial. Don't worry, I am covering all the basics before you are going to hit the topic, because I know it is corona lockdown. You will be at the home, there will be no teacher or anybody to teach you personally the basic prerequisites. So I will be taking care of all the things. I will be teaching you as a tutor, sitting in front of you and teaching you, so you will not miss anything. So let us start the topic polynomials. Let us go to our computer screen. Okay, let us start with the concept polynomial. What is polynomial is the basic question. Let us go back to our previous classes where we have learned algebraic expressions. Do you know, friends, what is algebraic expression? Yeah, you are right. I'll write the same. So algebraic expression is any expression that contains variables and constants, and a statement which is written in the form of mathematical statement is called as an algebraic expression. Let me write one example for algebraic expression. Suppose 2x plus 5 is a algebraic expression, and we call this algebraic expression as polynomial. Oh my god, it is so easy. And you may also think that what is the necessity of learning the whole chapter a polynomial when we have already learnt algebraic expressions? Because I am telling you that algebraic expression and polynomial are same. But friends, wait, there is a little difference between polynomial and algebraic expressions. Algebraic expression is a general term. Polynomial is particular type of algebraic expression. Then what is the thing that makes polynomial a special kind of algebraic expression? Let me show you how. Now I'll write one more algebraic expression. 2x to the power half plus 5. Yes. Is it algebraic expression? Yes. It has variable, it has constants, everything it has. Therefore, it is algebraic expression. Now, it is the time to examine whether given algebraic expression is polynomial. Guess, is it a polynomial? Yeah, absolutely. You don't know because you have not yet learned this polynomial, right? Okay, let me show you whether it is polynomial or what. The algebraic expression whose power is fraction See, here is one fraction, it is half, is not a polynomial. I am making negative statements here because in definition of the polynomial, negative statements are the heroes. Okay, not polynomial. Again, let me write one more algebraic statement. 2 to the power of minus 1 plus 5. Here, you just see the power of x, that is negative 1. So, any variable which has negative power cannot constitute the polynomial. It means this whole algebraic expression is not a polynomial. So these are two negative not having kind of things which makes a polynomial. Only thing is that all the algebraic expressions are polynomials except the algebraic expressions which have the power, the fraction and negative numbers. If you exclude these two kind of algebraic expressions, then all algebraic expressions will be your polynomials. I think it is very clear now. Here, everything whatever you have learnt in algebraic expressions will be your polynomials except the only thing that you have to take care in your algebraic expression there should not be any fraction power and any negative number power. That's it. Apart from that, every algebraic expression is polynomial. Now I think you have very much understood about polynomial. Let me make the statement or definition here. Polynomial is a, in short I'll write it as poly. Poly is a algebraic expression with powers, any kind of power you can have with powers except algebraic expression with powers of variable we have to mention here because variables are having powers, not the constants. Yes. Polynomial is algebraic expression with powers of variables except negative and fractions. Powers should not be negative numbers and fractions. Only this much, only this difference makes the polynomials stand apart. Okay, polynomial is algebraic expression with powers of variables except negative and fractions. This is definition of the polynomial. Now we will see the structure of polynomial. What is the structure? Structure means parts. Here we have a human body. We define its structure as head, leg, like that. Here we have to understand the structure of the polynomial. For that, let me write a polynomial. Suppose 2x square plus 7x minus 8 is a polynomial. Usually we write the polynomial by p of x is equal to. Now from now onwards we have to use this notation to write the polynomial. P of x is equal to 2x square plus 7x minus 8. Here in this polynomial, we have to understand the structure of this polynomial. Here, the numbers 2, 7, 8, they are fixed and called as constants. Constant means anything that will not change during any situation. Okay. Then what do we call the symbols or the things which keep on changing throughout the situation? Like here x square we have x square, the value of x square changes throughout the situation. Therefore, we call such symbols or such things as variables. While learning algebraic expressions, you have already learned this one. Okay, variables. And one more thing, if you consider these two with respect to x square, then we call this 2 as coefficient. 7 as also coefficient. Similarly, 8 also is coefficient. So, 2, 7 and 8 are also called as coefficients. Yes, they are coefficients. To call 2 as coefficient, we have to mention whether it is a numeric coefficient or variable coefficient. So 2 is coefficient of x square is coefficient of 2. In this way we have to say, and only one, that constant, it is numeric coefficient. Now I think you have understood. Here one more thing, every student is having confusion in 2x square. In 2x square, 2 is constant, you know. 2 is constant and x square is variable. My question is, if you consider 2x square as a whole, it means 2 times x square. Can you tell me whether it is a constant or variable, or it is something different from these two? Yes, your guessing is correct. 2x square is variable. Don't have confusion here because we call 2 as constant. But when it comes to the whole term, here we have used one new term. Every algebraic expression is having many terms. Depending on terms, we bifurcate, trifurcate them. So that thing we will do afterwards. Here you just understand this term as a whole is a variable. It is not constant because sometimes we say as it is having variable, it should be variable. But we also say here 2 is constant. So we have to consider the whole thing as constant. Nothing like that. I'll prove you how this 2x square as a whole is variable. You just go on assigning values to this x variable. You just see, I substitute 1 for this x. What happens, you see? 2 square of 1 is 1. Again, if you multiply 1 by 2, 2 times of 1 is 2. Here, again, I'll substitute some more number for x. That is, suppose you take 3. Right. 2. 3 to the power of 2 is 9. And 9 times of 2 is 18. See, first we had 2, now we are having 18. It means value of 2x square is continuously changing. Therefore, we call 2x square as variable, not constant. Yes, you should not think that x square as it is having 2, it should be constant. No, it's wrong. you have to consider this 2x square as a whole is variable. Yes. Now let us move to next concept, that is polynomials based on variables. Before going to learn polynomials based on variables, let me introduce one more word, that is term. This term is frequently used in polynomials, so we have to understand this word properly. What is the term? Term is a part of the polynomial, or term is the thing which constitute the polynomial, and polynomial is made up of one or many terms. Let me show you those terms. First, 0. 0 is a term and simply we call this as 0 polynomial. So sweet. 0 polynomial. Yes, it is 0 polynomial. Suppose I have a number, say 7. This 7, any number we call as constant polynomial. We call it as constant polynomial. Okay, now can I ask you one question? Whether 0 polynomial is a constant polynomial? Yes, 0 is a constant. It is a constant polynomial because value of 0 will never change. Same time, if I ask vice versa, like whether 7 is a 0 polynomial? No. It is one-way definition. Any 0 polynomial can be a constant polynomial, but constant polynomial cannot be a 0 polynomial. The polynomial with one term is called as monomial. Mono means one. Monomial. Mono means one, we have to write here. Okay. Now let me go to the polynomial having two terms, like 2x square, just we'll add one constant, say 5. 2x square plus 5. It has two terms. So we call it as binomial. Binomial. So bi means two. Similarly, if you have three terms, say 3x cube, 2x square plus 1x. It has three terms, term number 1, term number 2, term number 3. It has three terms, therefore we call it as trinomial. Trinomial. Tri means 3. 3. In this way, the story continues. Okay, let us move to the next concept, that is polynomials based on degree. Before going to the category of polynomials based on degree, let us understand what is degree. Degree, usually we call it as degree 100 degree. No, this is not that degree. Some kind of power only, because usually degrees give us the power, right? Okay. Now we'll understand what is the degree of a polynomial. For that, let me consider a polynomial. Again, I'll take the polynomial 2x plus 5. Now I'll write it as px is equal to. So p of x is equal to 2x plus 5 is a polynomial. We have to find out its degree. To find out degree of a polynomial, you just consider all the variables along with their powers. Here I have a variable here and its degree is and its power is 1, and we call this power as degree. Its degree is 1. Now let me write one more polynomial, 3x square plus 7x plus 1. Now whose power we have to consider, because we have two variables here. One is x square and other one is x. So its power is 1. Whether we have to consider the x square or x to the power of 1. Okay. For time being, let me consider the more power. Like, whose power is more here? Absolutely 2. So I'll consider the power of x as 2 as degree here. Okay, that is 2. Next, p of x is equal to 7 x to the power of 8 minus 7 x to the power of 2 plus 5. Here, I think now you have understood the rule, that is degree of this polynomial is 8, that is highest power of the variable. So by this we have, I think, understood the degree of the polynomial. Every time I'm not going to tell you directly, I'll keep the things for guessing, because by analyzing or by logical thinking from your side only you can understand the mathematics. So by one general conclusion we have understood that a variable which has highest power among its friends can contribute to the degree of the polynomial. So what is degree? Degree is power, highest power of the variables in a polynomial. So for general polynomial also we can write the degree, but here you have to guess or you have to tell the degree. Let me write the general form of polynomial. Do you know how to write the general form of polynomial? Usually what the teachers will do, they'll just write it on the board and you copy it, afterwards you'll just forget. But I'll not going to do that. I'll teach you how to write the general form of the polynomial. Here I'll start writing the general form of polynomial by a n minus 1. I'm decreasing their order, a n minus 2. In this way, if you go on decreasing, you will end up with a1 and lastly a0. Next, we have to multiply these things with their variables, like x to the power of n, x to the power of n minus 1 plus x to the power of n minus 2 plus, will continue in this way. At the end, a1x. Here our x closes and next we don't have variable here. Finally, we have constant. A0 means constant, you have to remember. Okay. Now can you tell me the degree of this general form of polynomial? Absolutely, you are right. You have properly understood. The degree of this polynomial is n, because it is the highest power among all the variables having degrees. Degree of this polynomial is n. It is very important. Okay. Now, based on degree, we will categorize these polynomials. First, we'll write a polynomial of degree 1, that is 2x plus 5. Yes, it is a polynomial of degree 1 because variable has only one power. I mean, its power is 1. Okay, we call such polynomial as linear polynomial. Linear polynomial. Now let me increase the order. 2x square plus 7x plus 8, like that. So its degree is 2. Now you have understood the degrees. You can say what is its degree. It is 2. Yes. The polynomial having the degree 2 is called as quadratic. It is quadratic polynomial. Similarly, you can write one more polynomial, 3x cube 7x square plus 9x plus 1. Its degree is 3. Don't worry about terms, you just see the degree. Its degree is 3. We call it as cubic polynomial. In this way, we can categorize the polynomials. Lastly, we can write the degree, uh, n degree polynomial in general. There we conclude. Now let me solve one or two examples for you, only to test how much we have understood. Okay, let me change the color. Yes, here, which one of the polynomial, which one of the following is a polynomial? Here, if you transpose this x to numerator, you will get x to the power of negative 2. So as here we have negative number, it is not a polynomial. We have to identify the polynomial in this group. It is excluded. Next we'll move to root 2x. It means if you separate them, you will have root 2 and root x. Root x means x to the power of half. So here as we have half, it is a fraction, and this polynomial, this algebraic expression cannot be a polynomial. Now this is excluded. Next we will move x to the power of 2. I'll keep it as it is, x to the power of 2, and this 3x to the power of 3 by 2 as it is 3x to the power of 3 by 2. What I'll do is, I'll transpose this root x to numerator. That will become x to the power of minus half. Now, as the bases are same, I'll add 3 by 2 with negative half. What I'll get is 2. It means x square plus, by simplifying this whole term, we have got one more x square. So totally we have 2x square. It means it is a polynomial. Then there is no necessity to uh, examine the last one, as we have got here the answer. So C is the answer. Now root 2 is a polynomial of degree. First let me show you what is root 2? Root 2 is constant. Its value will never change. Then you just remember what is the degree of constant polynomial. Yes, absolutely. Degree of constant polynomial is 0, because it has no degrees, because it has no variable. Therefore, its degree is 0. Now, degree of polynomial. Here they have given one polynomial, you have to find out the degree. To find out the degree, you just verify the powers of all the variables, which is the highest power. Here power of x is 4, 3, and here we have 5. But it's, if you see the number next to x to the power of 5 is 0. It means if you multiply x to the power of 5 with 0, you will get 0 as answer. Therefore, you cannot consider this one for the degree. So what is left is 4x to the power of 4. So it is having the power 4. Therefore, it will be the degree of the polynomial. That is 4. Answer is A. Next, degree of the zero polynomial. Degree of the zero polynomial is not defined because it is having constant. Moreover, it has no variable with it. So we don't know how to define it. Therefore, for this we have used the word not defined. That is the answer. Now it is time to get to some work. That is, write whether the following statements are true or false and justify your answer. I am not going to solve these examples for you because I am assigning this one as a homework for you to do at home. When you come to my next class, you have to have all these examples solved. Otherwise, you just wait for my next class. In the next class, first I'll going to solve these homework examples, then I'll move to next exercise. I think you have understood the concept very clearly and now you have got interest to learn more. In that case, please like my channel and subscribe to my channel and mm, on your bell notification so that whenever I upload a video, you will get a notification. Thank you.